kids, it's Mrs. Compton, and we're going to do your third grade chapter 7 review today. So get your workbooks out, get your pencils, and follow along with me. All right, so we've got number 1, Ming divided 35 marbles between 7 different friends. Each friend received the same number of marbles. How many marbles did Ming give to each friend? All right, so then we have 35 marbles divided amongst 7 different friends equals our answer. So we're using a letter A to show where the answer would be. Or you could think about it, solving it like this. You could do 7 times what number would give us 35 marbles. So here the 7 represents the 7 different friends. And each friend is going to get how many marbles? And then there's a total of 35 marbles, right? So you could count by 7 how many times to get to 35. So 7, 14, 21, 28, 35. So we'd have to count by 7 5 times. So our answer would be 5. So we could put B, 5. And then the same would be true. 35 divided by 7 equals 5. So A equals 5. Number 2, Mrs. Connor has 16 shoes. Select one number from each column to show the division equation represented by the picture. Okay, so there's a lot going on here. Let's look first. Okay, so she has 16 shoes. Let's see, of course, shoes are grouped in pairs of 2. All right, so we can see the picture. Select one number from each column to show the division equation represented by the picture. All right, so 16 shoes divided by, and then we have to figure out what number is going to go here and what number is going to go here. So it's showing us we've got the option for 1, 2, 4, or 16 for our divisor. So 16 divided by, well, they put them into groups of what? 16 divided by groups of 2. So see how there's 2 in each group? So I'm thinking that this might be our divisor. And then I'm thinking the number of groups is going to be our answer. So 1, 2, 3, 4, 5, 6, 7, 8 groups. So I think that's going to be it. So let's check and make sure. 16 divided by 2 equals 8. Is that true? The answer to that is yes. All right, number 3. 20 boys are going camping. They brought 5 tents. An equal number of boys sleep in each tent. How many boys will sleep in each tent? Okay, so we have 20 boys going camping. So 20 kids. And then they're going to be divided amongst 5 tents. So divided by 5. That will give us the number of boys per tent, right? So you could count by 5. 5 times a number. We could say 5 times a number, and we could just put the missing number right here. Makes 20. Some of you probably find that easier to count by 5s to get to 20. So if we did that, 5, 10, 15, 20, we know that it would be a 4 right here. So 20 divided by 5 equals 4. So right now I'm thinking 4 boys go into each tent, and that seems very reasonable to me. So let's see. Would that be true if we put 4 boys in each tent? Would that add up to 20 boys? Let's see. Let's count by 4s this time. Ready? 4, 8, 12, 16, 20. All right, so we've got it. The answer is 4. Circle a number for the unknown factor and quotient that make this equation true. Okay, so we have to read it like this. 4 times one of these numbers makes 28. And then on the other side, one of these numbers equals 28 divided by 4. I think I just want to look at one of these for right now. It's too much for the eyeballs. All right, there we go. So 4 times what number makes 28? Well, I know 4 times 5 is 20, right? So 4 times 6 is going to be 24. And 4 times 7 would get me to 28. So this one must be 7. All right, let's check out the other side now. So 28 divided by 4. Another way to think about this is how many times do you have to count by 4 to get to 28? 4 times what makes 28? So if you know the answer to that, then you know what 28 divided by 4 is. So maybe you would solve it that way. So let's try it out. 4, 8, 12, 16, 20, 24, 28. We had to count 7 times. So in both cases, the answer was 7, right? 4 times 7 makes 28, and 28 divided by 4 makes 7. They are fact families. Number 5, Mrs. Walters has 30 markers. She gives each student 10 markers. How many students received the markers? All right, so again, I think this is a lot for the eyes. So let's make sure we understand the story first, and then we'll go in and look at exactly what's happening. So Mrs. Walter has 30 markers. She gives each student 10 markers. All right, so imagine this. You get 10 markers, and you get 10 markers, and you get 10 markers. So then how many students receive the markers? So this is her starting number. I think I'll just type it. So that's her starting number right there, 30. And then this first person gets 10 markers, so she gives away 10 markers. So this is actually a person right here. Whoop, they get 10 markers, and now she only has 20 markers left. And then she gives another 10 away, so this is another person over here. So these minus 10 actually represent the students in the problem. And you get 10 markers. So how many people got markers? The answer would be 1, 2, 3. So write a division equation to represent the repeated subtraction. So it looks like we started with 30, right? So that'll be our starting number, 30. Divided by groups of 10. So she put them into groups of 10, and then there ended up with 3 groups of 10, or otherwise known as 3 people got 10 markers each. All right. Number 6, complete the chart to show the quotients. All right, so I'm looking at this, and it looks like 9 divided by a number. Actually, it looks like 27 divided by 9 equals what? I was thinking about it backwards. So let's make sure we know what this is showing us. 27 divided by 9 is going to give us a number here. So this one here is going to be 27 divided by 9, and we'll put the answer there. Okay, so how many times would you have to count by 9 to get to 27? Let's see, 9, 18, and then the next one would be 27. So this right here would be a 3. So then this one, it looks like it's counting by 9s. So it's increasing by 9s from 27 to 36. So that means here I'm going to increase my answer by one more group of 9. 9, 18, 27, 36, 45. All right, so we're going to increase again by one more group of 9. 3, 4, 5, and 6. Now we can even make sure that we agree with this. So this would be 54 divided by 9 equals 6. Do you agree with that? All righty, I do. Moving on, number 7. Ooh, there's so many things here. Let's cover. For numbers 7a to 7e, select true or false for each equation. All right, here we are. 12 divided by 6 equals 2. Well, if you have 12 things and you put them into groups of 6, each group, you will have 2 groups of 6, right? So that would be true. All right, next one. 24 divided by 6 equals 3. Well, 24 divided by 6, I don't know. That doesn't seem like enough. So 24 divided by 6, I think, is actually 4. So I'm going to go ahead and say false. 30 divided by 6 equals 6. Okay, if you have 30 things and you put them in groups of 6, will you have 6 groups at the end? The answer to that is no. Does anybody know what the real number would be right here? We'd have to change this number to make divided by 6 equals 6. Otherwise known as 6 times 6 makes 36. This would have to be a 36 in order for it to be true. All right, let's see the next one. 42 divided by 6 equals 7. Let's see. Let's say we don't know the answer to this one. How could we figure it out? So what might you do? You might use something that you already know. Like maybe you already know, let's see, 42, or maybe you already know this. 6 times 7. Do you know what that is? 6 times 7 makes 42. So that would make this one be a true story, right? Now, let's say you didn't have that fact memorized. You could always count by 6 7 times, or you could count by 7 6 times. And you could find out if that were true or not. All right. Last one, 48 divided by 6. And we have to figure out if that's really 8 or not. All right, so what do you think? Is it true or is it false? 48 divided by 6. How can you figure this out if you're not really sure? What would you do? You can always think about like your strategies for what would you do if you're not really sure, right? So you could check for a fact family like we did last time. Is 8 times 6 48? The answer to that is yes. That would make it true, right? Or you could think about counting by 6s or counting by 8s and seeing if you come up with the right answer. All right, number 8. Ooh, we've got a written response for this one. Alicia says that 6 divided by 2 plus 5 is the same as 5 plus 6 divided by 2. Is Alicia correct or incorrect? And explain. All right, so first we have to think about this, right? So 6 divided by 2 is what? I'm going to put a little hug around it. 6 divided by 2 is 3. Maybe you're starting to memorize that fact. And then if we add 5 to 3, we'll get 8. Let's check over here. What would you do first over here? Would you do the 5 plus the 6, or would you do the 6 divided by the 2? Well, in the order of operations, which we're probably learning right now, right? We have to do division and multiplication first in order from left to right. And then we do the addition and subtraction in order from left to right. So that tells me we have to do the 6 divided by 2 first because this one shows up first. So I'm going to put a little hug around this one. So it's going to be the same thing again. We have a 3 right there. So 3 plus 2 is still 8. So they both equal 8. So Alicia is correct. Let's see. We should definitely say something about the order of operations, right? So the order of operations. Now remember, operations are actually like when you operate on a number. Addition, subtraction, multiplication, and division are all operations. So that's the order of these things. The order of operations. Actually, I think I want to say in the order of operations, you have to divide before you add. Both equations are equal to 8. We could say something like that. It doesn't have to be exactly what I just typed here. You can have your own written expression or your own written answer, but you should mention something about the order of operations. That is why Alicia is correct. All right, number 9. Let's see here. Keith arranged 40 toy cars in 8 equal rows. How many toy cars are in each row? All right, so we can probably imagine this one, right? So he's got 40 toy cars. They're in 8 equal rows. Okay, so he has 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there is 8 rows. And how many cars does he have to put into each row to make this whole thing worth 40? Ooh, getting a little sloppy there. So let's see. Would it be more than 2 or less than 2? Let's try it out. 2, 4, 6, 8, 10, 12, 14, 16. Okay, so it's definitely more than 2, right? So how about 5? Is it more than 5, less than 5, or 5 exactly? 5, 10, 15, 20, 25, 30, 35, 40. Okay, so we got 40 when we came to the end. So each row will have 5 toy cars in it. So how many toy cars are in each row? The answer to that would be 5. And what we just represented was 40 divided by 8 equals 5. Alrighty, number 10, Bella. Bella made some cash. Bella made $21 selling bracelets. She wants to know how many bracelets she sold. Bella used this number line. Okay, so as I'm looking at this number line, it looks to me like each of her bracelets cost $3 because it's showing from a hop from 0 to 3 and then 3 to 6. So I'm going to guess that each one of these is representing 1 bracelet. So that's a 1 bracelet, another bracelet, another bracelet. Keep on keeping on. So we could also think about this as $21 divided into groups of 3, right? So $21 divided by groups of $3 per bracelet. And then we count up the hops because that's each hop is a bracelet. So 1, 2, 3, 4, 5, 6, 7. 21 divided by 3 makes 7. Number 11. Each picnic table seats 6 people. How many picnic tables are needed to seat 24 people? Explain the strategy you used to solve the problem. All right, so maybe this one you might want to draw a picture, or maybe you're starting to memorize. Who knows? You don't have to have them memorized yet, but we're working on it, right? So maybe you're going to draw out some picnic tables, and you're going to write 6 in each one. 6 people. That makes another 6 people, so 12 people so far. 6, 12. Ooh, maybe you're like, ooh, I know if I do 12 plus 12, that gives me 24. So maybe you're just like, oh, let me get rid of this one. Maybe you're like, I could just double these. Because if this makes 12 here, and 12 plus 12 makes 24, then you know you're going to end up with 4 groups. All right, so let's see. The question's asking me how many picnic tables are needed to seat 24 people. So 4 picnic tables are needed to seat 24 people. Let's see. It also says we have to explain the strategy we used to solve the problem. So I counted by 6 4 times and landed at 24 or something like that. You could also say you drew out the picture, but really we counted by 6, 6, 6, 6, and then we found out that 4 6s make 24. All right, number 12. Finn bought 2 packs of stickers. Each pack had the same number of stickers. A friend gave him 4 more stickers. Now he has 24 stickers in all. How many stickers were in each pack? Explain how you solved the problem. Okay, so Finn bought 2 packs of stickers. Each pack had the same number of stickers, and then a friend gave him 4 more stickers. Okay, so we have to think about this. If he ends up with 24 stickers at the end, but his friend also gave him 4, I'm kind of thinking like a number bond right now. So here's his 24 stickers at the end, but his friend gave him 4. So that means 20 stickers were in the 2 packs. So that means the 20 would be split into a pack of 10 and another pack of 10, right? So this represents 1 pack, 2 packs, friend's gift. There we go. Number bonds save lives, you guys, I promise. So Finn bought 2 packs of stickers. Okay. Pack 1, pack 2. Each pack had the same number of stickers. A friend gave him 4 more stickers. Now he has 24 stickers in all. How many stickers were in each pack? Okay. So we have to tell our answer and explain how we solved the problem. So there were 10 stickers in each pack. I took off the 4 from his friend, which gave me 20 stickers. Then I split the 20 stickers in half into 2 different packs. Something like that. You don't have to write that exactly. Remember, you can put your own thinking there. All right, number 13. Anna used 49 strawberries to make 7 strawberry smoothies. She used the same number of strawberries in each smoothie. How many strawberries did Anna use in each smoothie? Capitalize. This is a proper noun right here. Okay. So she had 49 strawberries that she used. Okay, so that's important. And she made 7 smoothies. She must be making smoothies for her friends or for her family, or maybe both. All right, so this is going to be a smoothie here. Let's see. 2, 3, 4. Okay, so here are my 7 smoothies. And all together, she uses 49 strawberries. So will she use 5 strawberries per smoothie? Or more than 5 or less than 5? Let's find out. I like to use friendly numbers as my estimates, my starting points. 5, 10, 15, 20, 25, 30, 35. Okay, so of the 49 strawberries, if we put 5 in each smoothie, we haven't used them all yet, right? We've only used 5, 10, 15, 20, 25, 30, 35. So we still have how many left to use? We still have 14 left. So now I know I can split my 14 into the 7 shakes. And you probably know 14 divided by 2, or 7 is 2. So we can put 2 more strawberries in each shake. So I used the distributive property to help myself, right? So I kind of broke up my number a little bit into smaller pieces. And then I helped myself make sense of things. So each shake received 5 strawberries and then 2 more. So 7 strawberries in total. So 49 divided by 7 is 7. Number 14. Ooh, got a cover. For numbers 14a to 14e, select true or false for each equation. All right, so let's see here. We've got 81 divided by 9 plus 2 equals 11. Okay, I think we're going to have to remember the order of operations here. So which one comes first? Is it divide or add? Division comes first, right? So let's put a little hug around this. So 81 divided by 9. Well, 9 times 10 is 90. So I know 81 divided by 9 is going to, the answer will be close to 10, but it won't be exactly 10. It's going to be 9. 81 divided by 9 is 9. Plus 2 is 11. Okay, so that's true. All right, number 14B. All right, so first, in the order of operations, should we do the addition or the multiplication? We're going to do the multiplication first. So remember, it's division and multiplication in order from left to right. And then addition and subtraction in order from left to right. So let's put a little hug around the ones that go first. It's just kind of a little helpful for the eye when you're learning. So 4 times 5 is 20. 20 plus 6 is 26. So it's telling me the answer has to be 50, so this one is false. All right, 14C. All right, which one is it? Addition or division? Which one comes first? Put a hug around it. 10 divided by 2 is 5. 10 plus 5 is 15. That makes this one true. All right, 14D, here it comes. Which one's first, subtraction or multiplication? It's multiplication first, so let's put a little hug around it. The hug is called parentheses, right? 3 times 2 is 6. And then we go back to the start and we go 12 minus 6. So does 12 minus 6 equal 6? The answer to that is yes, true. All right, 14E, 20 divided by 4 times 5. Okay, so this one, see how there's a division and a multiplication? So division and multiplication. They have the same power. So we're just going to go in order from left to right, whichever one shows up first. So the division shows up first, so that's the one we're going to do. So what is 20 divided by 4? 20 divided by 4. 4, 8, 12, 16, 20. So we could count by 4s 5 times to get to 20. 5 times 5 is 25, not 1. So that makes this one false. All right, next up, number 15. A flower shop sells daffodils in bunches of 9. Okay. It sells 27 daffodils. How many bunches of daffodils does the shop sell? All right, so we've got daffodils in bunches of 9. So if this is a bunch, we'll put 9 in there. And if this is another bunch, we'll put another 9 in. Have we gotten to 27 yet? Nope. We have only gotten to 18. So we need another bunch. Have we gotten to 27 yet? 9, 18, 27. We did. So we ended up with 3 bunches. 1, 2, 3. So it's important that we don't put 27 right here, right? Because we were just counting up until we got to 27. This is our answer, the number of bunches. This is 1 bunch, 2 bunch, 3 bunch. All right. Next up, we've got another one of these little charts. All right, so let's look at it first. Aviva started a table showing a division pattern. Okay. So I think it's going to be kind of like the last one. 20 divided by 10 makes what? You probably know this one. 20 divided by 10 makes 2. 30 divided by 10 makes 3. 40 divided by 10 makes 4. 50 divided by 10 makes 5. Okay, now we're going to add another piece to the puzzle. 20 divided by 5 makes what? We're going to put the answer here. So now we're doing 20 divided by 5. So now we're going to do this row right here. All right, so 20 divided by 5 is what? 4. 30 divided by 5 is, how many times would we have to count by 5 to get to 30? 5, 10, 15, 20, 25, 30. We'd have to count 6 times to get there. All right, now we're going to do 40 divided by 5. Okay, so how many times would you have to count by 5 to get to 40? 8 times. And then 50 divided by 5 is 10. You probably know that because 10 times 5 is 50. All right, so now, whoa, got a color change. Part A says complete the table, donezo. Now we have to compare the quotients when dividing by 10 and when dividing by 5. Okay, so now we're supposed to look at the quotients. Let me just take these out so we can concentrate. There we go. Bye-bye. Bye. Okay, so we're going to compare, like, if you're dividing by 10 and if you're dividing by 5. All right, so when we had 20 divided by 10, it was 2. When we had 20 divided by 5, it was 4. Okay, so I kind of like to put a little situation with this. So if we had 20 people and they were sharing 10 pieces of candy, each person would get 2 pieces, right? Okay, now if we had 20 people and they were sharing 5, or sharing, did I say that backwards? Let me go back. Hold on one second. So 20 people, or 20 pieces of candy shared by 10 people. Each person gets 2 pieces of candy. I did say it backwards. Okay, so now we're thinking about 20 pieces of candy divided by 5 people, shared equally amongst 5 people. Each person would get 4 pieces of candy. So you'd get more candy because there's less people to share it with, right? So we had 2 and 4, 3 and 6, 4 and 8, 5 and 10. So do you notice anything as you are looking here? It says describe a pattern you see in the quotients. Do you notice anything there? I'm noticing a connection between the 2 and 4 and the 3 and the 6, the 4 and the 8, and the 5 and the 10. So it looks to me like when you have half as many people, so like we went from 10 people down to 5 people, you get twice as much candy, right? So how could we say this one? The quotient, when dividing by 5, the quotient is double. I think I'm going to say that. When dividing by 5, the quotient is double. Quotient is when dividing by 10. All right. So this is part B now, right? So we've already filled in this on the last page. So we had 2, 3, 4, 5, and we can put those in here again. So 2, 3, 4, 5, 4, 6, 8, 10. All right, find the quotient A. 70 divided by 10 equals A. All right, so basically it's just saying put the answer there. So if you have 70, well, we could continue this pattern, right? So we could do 50, 60, whoa, 70. 70 divided by 10 would make, this would be a 6 and this would be a 7, right? So we can extend our patterns. How could you use A to find the value of N? Find the value of N. Okay, so they're saying, like, if you know this one right here, how can it help you find this one right here? Because they're saying now they want 70 divided by 5, and that's going to be the missing number right there. So what could we do to figure that one out? if we knew this one, 2 doubled to 4 and 3 doubled to 6. Then 7 is going to double to 14. So we can use the pattern that we found to help us extend our thinking. All right, now what would you say there? How would you explain how you found your pattern? Let's see. Maybe I could say I doubled the 7 from A and made it 14. All right, number 17. Ben needs 2 oranges to make a glass of orange juice. If oranges come in bags of 10, how many glasses of orange juice can he make using 1 bag of oranges? All right, so here's this glass of orange juice. He's going to put 2 glasses in there. And in total, he's got 10 oranges. So 2, 4, 6, 8, 10. Now our answer is not 10 glasses, right? These are the glasses here. So our answer is 1, 2, 3, 4, 5. 5 glasses of orange juice. Number 18. Oh, we've got another one. One that needs a cover. There's too much going on for my eyes here. All right. You can always cover yours too if it's too much for your eyes to look at as well. All right. 0 things divided by 9 equals 0. Okay, so if you start with 0 and divide it by something, do you end up with 0 at the end? Well, the answer to that has to be yes, because you're not going to have anything if you start with nothing. So, true. 9 divided by 9 equals 1. Okay, so 9 cookies divided by 9 people. Each person gets 1 cookie. Answer, true. 27 divided by 9 equals 4. Well, I remember we did a question with, I think it was daffodils. And there were 9 daffodils in a bouquet, and we found out 9, 18, 27. We only had to count by 9 3 times to get to 27, so this one's false. 54 divided by 9 equals 6. And let's see. Maybe you know how to count by your 9s, or maybe you're learning how to write your 9s going down. 9, 18, 27, 36, 45, 54. Some kids like to write them going down because we can see lots of patterns. 9, 8, 7, 6, 5, 4. 1, 2, 3, 4, 5. So let's see. We counted by 9 how many times? 1, 2, 3, 4, 5 times. Wait. 1, 2, 3, 4, 5, 6 times. And we got to 54. So that one's true. All right. And then 90 divided by 9 equals 9. You might be thinking to yourself, I thought it was supposed to be 10. 90 divided by 9 would make 10, right? So we know that one's not really true. So we've got to hit the false button. False. All right. Number 19. Ellen is making gift baskets for 4 friends. She has 16 prizes she wants to divide equally among the baskets. How many prizes should she put in each basket? Okay. So she has 4 friends. All right. So we'll put a friend here, and then a friend here, here. Okay. Actually, these aren't friends. These are the gift baskets. But the gift baskets have to be match the same number of friends that she has, right? Okay, so she has 16 prizes she wants to put in. So will she put in more than 2 or less than 2? Let's see, 2, 4, 6, 8. So she's going to put in more than 2. How about 3? 3, 6, 9, 12. Nope. How about 4? 4, 8, 12, 16. And when we put 4 in, we got to our winning number, 16. So each gift basket is going to get 4 prizes. Lucky party participants. All right, here we go. Number 20. Oh, it's a 2-parter. Emily is buying a pet rabbit. She needs to buy items for her rabbit at the pet store. Emily buys a cage and 2 bowls for $54. The cage costs $40. Each bowl costs the same amount. What's the price of 1 bowl? Explain the steps you use to solve the problem. Well, you guys, you know my secret, right? You know I love number bonds. So I just love to use them as I'm thinking. So here's my $54. There's my total, right? Then we know that the cage costs the most, right? So here's the cage, $40. And then we know that there's $14 left, right? So you could even put cage and then you could put bowls. And it says she bought 2 bowls. So I have to split this 14 into 2 parts. And I know 7 plus 7 is 14. So I know I'm going to split it into the 2 parts like this. Right? So what's the price of 1 bowl? There we go. Easy peasy. We found it. It's $7. Explain the steps you use to solve the problem. Okay, so each bowl costs $7. I found my answer by subtracting the cost of the cage and splitting the remaining amount by 2 bowls. Right? So we subtracted out that 40, found out we had 14 left, and then split the 14 into 2 different sections representing each bowl. All right, here comes part B. Emily also buys food and toys for her rabbit. She buys a bag of food for $20. She buys 2 toys for $3 each. Write one equation to describe the total amount Emily spends on food and toys. Okay, so we actually need to see the last page too. So let's see. There we go. So because it says we have to have one equation for food and toys. All right, so what could we do here? I want to pause just to kind of give you some time to think about this. So what are you thinking? All right, so I know that she's going to buy 2 toys for $3 each. That sounds like multiplication to me. Does it sound like multiplication to you too? I also know she's buying a bag of food for $20. Oh, you know what? I guess we don't need part A, but that's okay. We can keep it here. All right, so write one equation to describe the total amount Emily spends on food and toys. We have everything we need right here on this page. All right, so here's the cost of the food, $20. Let's type it. $20. So she had that, plus she also bought 2 groups of toys for $3 each, right? And that equals our total cost. So I could say C for cost. All right, so how would we solve this though? So if we were using the order of operations, would we add the 20 and the 2 first, or would we do the 2 plus the 3 first? So it says explain how to use the order of operations to solve. So first, I would multiply the 2 times 3. And that makes sense, right? Because that represents the 2 toys for $3, which is 6. Then I would add the 20 to the 6, which makes 26. All right. Does that make sense to you? It seems like she spent $26. So 2 toys for $3 each and a bag of food for 20. All right. And then, of course, you want to make sure you have your answer that she has spent $26. All right. And I put my $sign in at the very end there. All right, kids, that's it for your review. I wish you luck and make sure you have your written explanations and you show your work. See you next time. Bye.